Hi, this is Mrs. LaBarbara. This is AP Physics Mechanics C. Today, I want to talk about a question in rotation motion. This is a question from past the AP exam in 1984. So, amusement park ride consists of rotating vertical cylinder with rough canvas walls. The floor is initially about halfway up the cylinder wall as shown. After rider has entered and the cylinder is rotating sufficiently fast, the floor is dropped down, yet the rider does not slide down. The rider has mass 50 kilograms. The radius r of the cylinder is 5 meters. The angular velocity of the cylinder when rotating is 2 radians per second, and the coefficient of static friction between the rider and the wall of the cylinder is 0.6. So part A on the diagram below, draw and identify the forces on the rider when the system is rotating and the floor has been dropped. So when the floor has been dropped, the forces acting on the persons are, you definitely always have a gravity, which is going downward. And the person is not moving downward, so there must be an upward force supporting the person, so the person is in equilibrium in the vertical direction. So what is the force that making the person rotating? That is coming from the cylinder wall. That's called a normal force. So we have downward force, which is mg. We have normal force from the wall, the upward force. This upward force actually is friction force. It's between the person and the wall. That's the force is holding the person up. B. Calculate the centripetal force on the rider when the cylinder is rotating and state what provides this force. So centripetal force, let's go back to our equation. Centripetal force, Fc equals mv squared over r. V, because it's rotating, so V equals to rho omega, r times omega, whole thing squared. You can cancel out r, becomes mr omega. We know what m is, we know what r is, we know what omega is. You can figure out Fc, which is 1000 newtons. Next part, don't forget this part. What is the force providing that centripetal force? We know from this diagram that's a normal force. So normal force N is the one that's providing the centripetal force. Part C, calculate the upward force that keep the rider from falling when the floor is dropped, and state what provides that force. So this upward force has to be equal to downward force because the person is stuck to the wall, is not moving up or down. So that is the force, has to be equal to mg, which gives you 490 newtons. What is the force that's providing this force? And that is the friction force. Static friction force provide this upward force. So some of you probably say, well, if it's static friction, can I use the equation Fs equals to mu times n? You cannot, because this equation, what we're given, 0.6, that's a maximum static friction. Remember, static friction can be changed. So at this point, you have 490. If you go faster, static friction can be a little bit bigger. So it can change. You cannot use this equation because this equation gives you maximum static friction. Last part, at the same rotational speed, would a rider of twice the mass slide down the wall? Explain your answer. So from our experience, you probably say no. You probably experience that when people go for this ride, it doesn't matter. It could be a little person, a little kid, or could be a grown-up. So obviously they don't have the same mass, but nobody falls down. But why is that? Why nobody falls down? Let's take a look. So here is the reason. If the mass doubles, the normal force will double because normal force has m inside. It's directly proportional to the mass. So when mass doubles, normal force doubles. As a result, your friction has to double because friction is proportional to the normal force. So the increased friction will overcome increased weight. So the rider with twice the mass will not slide down the wall. Mathematically, you can figure out, we know maximum static friction has to be always greater or equal to mg, otherwise the person will fall. Maximum static friction is mu s times n, and n is mr times omega squared. You see this equation, m cancels out. So that means in this equation, mass doesn't matter. So the mass cancels out in this equation. The motion of the rider is not actually affected by the rider's mass. So that's it for this question. Thanks for watching. See you next time.